All right, my friends, welcome to the math review for 2024 SHSAT Test A. So for those of you if this is your first time listening to one of my videos, I'll give you the general kind of spiel in advance about the SHSAT. That I've been teaching SHSAT and SAT for about 20 years. Seen all the changes that have kind of come and gone over that time. So the one thing I'm going to really kind of want to focus on is that this is not, it's not a computations test, right? It's a test on strategies, right? So this is not, most of the content are not things you'll explicitly get in your regular classroom, right? I teach 8th grade in New York City public schools. Some of it is, right? Some of the computations that you see here, but for the most part, it's about strategies, right? So I always say if you're doing some terrible, brutal computation, right, that you missed something, right? You missed the purpose of the question, right? When they create these questions, there are specific things in mind that they're looking for and specific strategies that they want you to use. And if you don't use those strategies, it's not to say you're not going to get the right answer, but you may spend 2 to 3 minutes on something and burn up a lot of time, whereas someone else that knows the strategies can do it in 10 or 15 seconds. So that's one of the things I'm going to focus on. I'm going to show as many strategies as possible. So if you like one or you like multiple, if you can always kind of fast forward or go back to things. I tend to go kind of fast because these videos get kind of long otherwise. And if you have any questions, you post them in the comments and I'm happy to answer them for you. All right, so we'll get started with the first one. There's not really too much to do here, honestly, right? So this is just a computation. So probably we want to take this and we want to add the opposite, right? So we want to make this a positive 1 1/10, right? So we can add the positive 2 3/10 and the positive 1 1/10, and we get 3 4/10, minus or add negative really, right? And we should get negative 4/10. Not really much to say there, right? Not any specific strategy. Just again, you can fast forward this if you need to. Another one, a little speech. So they do put some computational things as far as fraction, decimal work, integer work, order of operations, absolute value, just because they know, the extent to which kids nowadays in New York City get calculators, right? So you get your calculator in 7th grade, you have it for the whole state test. Sometimes you get it for the whole year. A lot of times you never learn our integer rules, our decimal rules, our fraction rules, all those good things that we should know. And especially high schools obviously feel that if you're going to go to a specialized high school, you should know how to multiply decimals, let's say, right? We don't need to multiply or divide 4-digit numbers, right? That we can use a calculator for. But sign rules and order of operations and things like that, we definitely want to make sure that we know. And obviously we have no calculator for this test. All right, so let's get to 59. We do need to know complementary, supplementary. All right, we could see as many as, let's say, 2 or 3 of these types of questions without a picture. So the last time I proctored, you see a little combination of both. Sometimes you'll see a picture, sometimes you'll see something like this. And if we see something like this and you don't know complementary versus supplementary, you're going to be kind of stuck, especially on a question like this where there's no choices. So we know complementary sum of 90, supplementary is going to be sum of 180. So we have one angle that's 5 times the other, right? So if the measure of r is 5 times m, we want to call x, we want to call r 5x. We know that 5x plus x, which is 6x, equals 180. Dividing by 6 gives us, obviously, x is equal to 30, but that's the measure of angle m. So if we go back and substitute, we know this is going to be 150, right? We know the angles are in a 5-to-1 ratio, so if you want to be kind of more savvy about this, knowing they're in a 5-to-1 ratio, you know that angle r is going to be 5/6 of the total, right? Because 5 parts to 1 part is 6 total parts. This is going to be 5/6 of that 180, and 180 divided 6 is 30, divide 5 is times 5, is 150. Number 60, kind of an odd one, right? Interesting question, right? So it says, so this is one of the things when they made some of these changes around kind of COVID, like 2020, 2021, they decided to put on maybe about 20 or so percent questions that are 7th grade state standards, which they had never really done before, right? We had never seen a proportional relationship question, unit rate, stuff like that prior. So now we see a handful kind of sprinkled in here, and this is one of them, right? We see a few unit rate questions in this test. How many gallons of apple juice per gallon of cranberry juice? So when I see the word per in a unit rate question, I know that that's going to be my division. So I'm going to say apple juice per, which is divided by cranberry. Now that alone is going to be enough for me to solve this, right? So if my apple is 3/16 and this is 3/40, What I could do is I could straight up divide. That's probably going to be the simplest way. And we'll talk about some other kind of different outside the box ways. And if you don't like it, again, you always fast forward. So this is going to be the kind of straight up division method, right? So I'm going to divide, which means I'm going to multiply by the reciprocal. Clearly I can divide out the 3. I can divide out 8. And I get 5 halves left over. They want the answer as a decimal. So obviously as a decimal, this is going to be 2.5, which is going to be 2 5/10. Now, maybe a better way to do this, right? So we want the denominator to be 1, right? We want to know per gallon. We know per is for every 1. So if I want 1 gallon of cranberry, I'm going to multiply the numerator and denominator by the reciprocal of the cranberry, which is 3/40. Now, I don't need to do any work in the denominator because I know that any fraction times its denominator has a product of 1. So when I do the work in the numerator, I end up with the same exact computation that I had down here. So a different approach ends up with the same computation, which gives us 5 halves. A kind of unusual way of doing it also, as an aside that works, is the same way that if we had, let's say, something like 3/7 to, 5/7, right? If this is my ratio, since the denominators are the same, I can just take the ratio of my numerators. We can do the same thing with the denominators just reciprocally. So since the numerators are the same, I'm going to end up with the reciprocal of the denominators, or the quotient of the denominators, which is going to be 40/16, which is essentially, again, what we end up with here, right? So unusual to do because usually we think common denominator instead of common numerator, but it works in the same way. Since the denominator has the 40ths, those are the smaller pieces, so we have to do 40 divide 16 to find the ratio. But again, mathematically it works, so we have a lot of different strategies for something like this. All right, 61 should be a pretty easy one. Right, so it says Mr. Chan's lawn was 4 inches tall at the beginning of the season. Now it says it grows 2 1/8 inch every 2 weeks, and also every 2 weeks he's cutting 1 3/4. So why don't we just find the net difference here, right? So it's growing 2 1/8, and then when it does that, he's cutting 1 3/4. So we should know 1 3/4 is 1 6/8. So the difference of 2 1/8 and 1 6/8, if I count up by eighths to 2, from 6/8 to 2 wholes, right, is 2/8 plus another eighth is 3/8. So my difference is 3/8. Now that's what's happening every 2 weeks. Now we want to know what's going to happen after 8 weeks. So after 8 weeks, this net difference of 3/8 is happening 4 times. So that's going to be 12/8, which is 1 1/2. Okay, so that's the total net difference there. And if I take what we started with, which was 4, and I add the 1 1/2, right? That's a result of the 3/8 total growth every 2 weeks, 4 times, right? Because in 8 weeks, there's 4 2-week periods. That's 12/8, 1 1/2. So we add that to the 4, and we get 5 1/2. All right, 62. So this is an important one, right? Because a lot of the times we struggle with questions like this, especially if the number is pretty big and they give us a table. This one is very, very problematic. I would star this one, and I would find other questions to practice. So really focus on this when we see some of these questions. So what's the median? Well, I certainly don't want to list out, this says that there's 45 zeros. So if I was listing this out, right, if I wanted to see all of these 110 families, I would have a pretty big list, right? So obviously we're not doing that. So I'm going to say, well, how can I figure out of 110 what's the median? Well, let's think about something simpler, right? Let's cut it down to 11, right? If there were 11 families, an odd number of families, the way we find the median is we add 1 and divide by 2, right? So if I had 11 families, the 6th one is going to be the median, which should make sense, right? Because if there's 11 groups, 11 numbers, the 6th one is the middle because there's 5 below and 5 above, right? So 5 plus the 1 in the middle plus the 5 gives me 11, right? So this one here would be the 6th, right? So that's the median. Now with an even number of values, we know the median is the average or the mean of the 2 in the middle. So I'm going to say, well, 110 divided by 2 is 55. So it's going to be right between the 55th number and the 56th number, right? If I listed all of these numbers out, there's 110 numbers, and if I sliced it right in the middle, that would be between numbers 55 and 56. So we realize that in this first column, there's the first 45 numbers. I want to know what the 55th number is and the 56th. Well, both of those are going to be here because the next 32 numbers will be 1s. So if we visualize a list, we're going to have 45 of these zeros, and then I'm going to have 32 of these ones, right? And somewhere in the middle, actually, 10 and 11 ones into this sequence, I'm going to have the 11th one. I'm sorry, the 55th and the 56th one. So what is the median going to be? It's going to be 1, right? Because that's going to include the 55th, the 56th. It's going to include a lot of values, obviously, but it will definitely include those values. All right, so now we get to the multiple choice. So we'll talk about some strategies for using choices. We'll talk about some picking numbers. We got a lot of different things to discuss. 63 I remember doing with my students last year, and they kind of had a tough time with this one. Maybe it's the how many more. There's a bunch of steps. None of them are especially difficult. So we got Mr. Jones and we've got Mr. King. And it says Mr. Jones has 550, which is, and maybe that's the hard part, 10% more than Mr. King. So we're going to say, well, if Mr. Jones has 10% more, right, then 10% more is synonymous with 110% of, right? Because we all have, right, whatever we're talking about, right, this pen in my hand, I have 100% of it. So if someone says they've got 10% more pen than me, they have 110% of my pen, which is kind of a silly analogy, but it works. Same thing with the goats, right? His 550 represent 110% of Mr. King's. And obviously Mr. King has all of his goats, right? He's got 100%. So we could think about this as a proportion, right? If Jones has 550 to King's X, great band by the way, but that's neither here or there, we've got 110 to 100. That's my proportion. Now these proportions we need to be able to have good strategies to solve quickly. No one's cross-multiplying this, I hope. Now, really good strategy, guys. You can simplify a proportion vertically or horizontally, right? And we don't always learn that in school. We learn to simplify fractions, but I can simplify horizontally. I can divide by 110, right? And the reason I can do that is because if I've got a proportion, I can switch the cross products. If I want to switch B and C, right? And this is something else we don't always learn in school. The cross products are the same. A times D is equal to B times C. A times D is equal to B times C, which seems like a subtle change until we throw numbers in there, right? And the other thing we can do then is that allows us to rewrite this if we wanted to. So we can simplify horizontally or vertically, just never diagonally, because diagonally those are the numbers that need to be multiplied. So now this seems like a pretty easy proportion. 1 times X is equal to 5 times 100, so X is equal to 500. Now D seems like a good choice, but until we read the question, and they bolded for us. How many more goats? Well, now we're just taking the difference of 550 and 500, so it's going to be 50. Okay, so that one's a little bit tricky at the end. There were a lot of steps, right? None of the steps were hard, but there were definitely a lot of steps. All right, next one I think should be pretty easy. This is another one of those things, right? We do all this algebra in school, even if we do algebra 1. We don't ever really deal with variable denominators, right? That's not like a standard that we'd see in algebra 1. So obviously we want to find a common denominator. Now the common denominator is going to be 2x. So if I multiply my numerator and denominator by 2, 2y divide x is really 4y divide 2x. And now I'm subtracting 1y divide 2x. So since I have a common denominator, I subtract the numerator and keep the denominator. And we get 3y divided by 2x, right? That should have been pretty straightforward. All right, 65, shaded region question. All right, so we do see a pretty good amount of these, or at least we used to, right? I know a lot of the practice tests have them. Talking to students who take the test, sometimes we see it, sometimes we don't. But certainly there's a lot of different possible variations, right? The circle could be inscribed in the square or vice versa. We could have a quarter like we have here. We could have half. So let's kind of think about how we can attack this question, right? They only give us one number, but that's all we need because it serves multiple purposes, right? The area of the square is 4. We should know that if the area of the square is 4, that's the side squared. So we take the square root, right? Because right now, if I multiply 2 by 2, I get my area, which is 4. So that doubles as the radius of the circle. So we need to find the area of the circle, right? So we should know area is pi r squared, right? If we don't know our area and circumference formulas, guys, you need to know them for this test, right? They're not going to give them to you. There's no formula sheet like there is on the state test or even on the Regents. You need to know area, circumference. Some other formulas are handy, which we'll talk about, but make sure we know those. So I know the area of the circle is going to be pi times the radius squared. So the radius is 2. So the area of my circle is going to be 4 pi. Now, obviously, I don't have a full circle, right? I've got this right angle. Now, the right angle, first of all, we should be able to tell it's a quarter. But if not, we say, hey, I've got 90 degrees out of the full 360 in a circle. Oh, yeah, I've got a quarter. So what's a quarter of 4 pi? Just 1 pi, right? Which is going to be choice B. All right, 66. This is one of the tougher ones, right? So this is a question where you may want to think outside the box a little bit, right? So we'll talk about a lot of different strategies, or a few different strategies, but I'm going to say, all right, well, what if I take some simple numbers, right? 5, 6, 7, 8. So now let me look at the question, right? A list of consecutive integers begins with m, which in this case would be 5, and ends with n, which in this case would be 8. N minus m is 66. Well, if I do n minus m here, in my example, n minus m is 3. But I have 4 numbers. That should be enough, honestly. Right? So the number of numbers, based on the pattern, which should hold, right? I mean, I can prove it algebraically, but not in the 30 seconds I'm going to have on the day of the test. This should hold. So if there's the difference of the numbers is 3, there would be 4 numbers. So if the difference of the number is 66, I would speculate then there should be 67 numbers. Okay. We could also think about using some numbers, right? So let's say that the first number is, in order for this to be 66, n has to be 66 bigger than m. So let's make this easy. Let's make m1, sorry. So in order for the difference to be 66, n would have to be 67. Okay, well that seems like it makes sense, right? If m, the first one, is 1, and we go out to 67, the difference is 66, then clearly we have 67 numbers. So we have pretty good proof there. Could we make the first one x and the next one, x plus 66? Yeah, we could do it that way, right? If you really want to be fancy, you could add m on both sides and do it like that. I think we're good, though, on this, using those two strategies. 67, all right, so we have a lot of ways that we can do this one. This is another one that kids had trouble with because there's a lot to do here. All right, so I'm going to start with what is probably the best strategy, I think, right? So I've got this 39 and I've got this 39, right? So if we're super savvy and we've done a lot of factoring, we can factor out the 39s. All right, maybe not going to do that, right? So let's think about dividing by 13, right? So I'm going to do it by the book afterwards. I'm going to do picking numbers. Right, so there's a coefficient of 39 here, right? This whole expression, right, the whole thing here in the brackets has a coefficient of 39, and there's a 39 here. And 13 is obviously a factor of 39. So if I divide everything by 13, this becomes a 1, this becomes a 3, this becomes a 3. So now I've got 3 times the quantity x minus 3 divide 3. The denominator is 1, so I don't need the denominator anymore. And then I've got plus 3 out here. Now I can do the same thing here. I've got 3 groups of x minus 3 divided by 3. I can divide out the 3. X minus 3 plus 3 is x. Okay. So that's method 1. All right. Let's get rid of some of this and let's try this again. Let's say we want to do it more kind of by the book. All right. So by the book, and this is not really what I would say they want you to do, right? By the book is going to be tougher because, oh man, well, okay. So let's do modified by the book. All right. Let's simplify the 39 and the 3. Right? I don't really, not that, we can multiply 39 by 3 and get 117, but now we're doing work, right? Too much work. We want to avoid that, right? Anyone could do that. So let's at least do the 39 divide 3, so 13. Okay, so I could distribute the 13, right? 13x minus 39 plus 39 divide 13. That makes this pretty easy. 13x divided by 13x, right? So either of those strategies is going to be good. That's what they want you. They want you to do something like that, right? They don't want you to distribute the 39 to the x and the negative 3, divide both of those by 3, add the 39, big expression, divide by 3. Now, let's say your algebra is just not at any of those points, right, where we're not going to do any of those things, right? We want to pick a number. And the number that's going to make things easy for me is going to be 4, right? I mean, 3 will be okay. I'm going to pick 4, right? I'm going to say, well, what would happen if x is 4? Well, if x is 4, 4 minus 3 is 1. 39 times 1 is 39. 39 divided by 3 is 13, which means I'm going to have 13 plus 39 divide 13. I'm going to have 52 divide 13, and I'm going to get 4. Right? And I'm going to say, that's interesting. I picked x as 4, and my answer was 4. My answer was x. Okay, so that's a way we can do this using picking numbers. Again, I would not pick a number like 372 because we're going to end up with huge computations. You'll still get x, but x is going to be 372, so probably not the best idea. 68 is a very easy one if you read the question, and this is a super common one, right? Because it says 1/4 of the water, right? Not a quarter cup, right? A quarter of the water. So if there's half a cup, a quarter of the half cup is an eighth. And this is like a very basic barometer. If you've prepared for this test before, you're looking for this. If you're not, you're going to make a mistake, maybe not make a mistake, but it's going to take you a while to decode the question. Right, so how much is in jar 2? Well, we have the half that was in there plus the quarter of the half, which is an eighth that we took from the other one. So we should know a half is 4/8 plus an eighth is 5/8. So 5/8 cups. All right, for the next one. So it says 1/100th, right? So obviously we want to start by writing this as a fraction. And it says it's between 1 out of n and 1 out of n plus 2. All right, so could we make an inequality, right? Yeah, I guess we could do that, right? I wouldn't say that that's at all necessary, but we should be able to tell that, I've got the fraction 1 out of 100. What's that going to be a little smaller than? Well, it's going to be a little bit smaller than 1 out of 99, and it's going to be a little bigger than 1 out of 101, so the value of n should be 99. Also, the choices there are kind of ridiculous, right? You can't have 0 as a denominator. That's a throwaway choice. It's not between 1 and 1/3, because clearly it's way smaller than that. It's not between half and a fourth, so none of the other choices are even reasonable. All right, 70. This should be a quick, easy one, right? So, again, this is another one. Maybe we'll see some proportion simplifying strategies. So 72% of the people answered yes, 56%. So we know that means 28% is going to be our no's. So there's 56 people. Okay, so 28%, right? 56 people out of the total is equal to 28%. They made this nice and easy. So again, I can simplify vertically or horizontally. So if I simplify horizontally, I divide by 28. Now when I cross multiply, I get x equals 200, right? Very simple. 71. So this scale drawings questions have been increasingly common. This is not a difficult one, but not super easy, right? So I'm going to draw my beautiful rectangle here. It says the area is 960. Okay, so that doesn't help me yet. It says in a scale drawing, 1 inch is 20 feet. Okay, so the length is 2 inches. Now, length and width are arbitrary, right? It doesn't necessarily mean that's the longer one. It does turn out to be that. So we've got 2 inches. Okay, so 2 inches would be 40 feet. And I know the area is 960 feet. So if I want to find the width, I'm going to divide the area by the length. Right? So if I know that 100 divided by 4 is 25, 96 is one less group of 4. So that's going to be 24 feet. All right, so far everything's fine and good. If I check this and I multiply the numbers, it gives me 960 is the area. Now it says what's the width in the scale drawing, right? So what do they tell us? That 1 inch is 20 feet. Okay, so if 1 inch is 20 feet, what is 24 with regard to 20? Well, it's a little bit bigger. Well, that's not going to help us too much because, we know it's going to be A and B, but we need to simplify this. So if I divide by 4, I get 6/5, which is going to be 1 1/5. All right, 72. It says we're generating whole numbers from 1 to 9 inclusive. So we need to know that word means including those numbers. So the word between in math is kind of funny because technically between doesn't include the things, right? If I say find a number between 1 and 2, you wouldn't tell me 1, I hope, right? You'd say a third, you'd say, 2/7, but you wouldn't say 1, you wouldn't say 2. If I throw inclusive in, inclusive means including those things. So it says there's 300 numbers. What's the best prediction of the number of odd numbers? Well, we've got 1, 3, 5, 7, 9. So 5/9 is the probability of drawing an odd number every time. So I'm really taking 5/9 of 300. Now, I don't need to do any math here, right? So this is a specific strategy, right? 5/9 is bigger than half, right? Half of 300 is going to be 150, okay? So all of these are out. I don't have to do anything, right? Sure, I can, if I really want to check it, if I have a ton of extra time, I'll divide by 3, and I'll get 500 thirds. And 500 thirds is going to be what? 166 2/3, right? So it's going to check. But really, this is a question about using reasonableness and using choices, right? We should eliminate all the choices that are half or less. It's got to be the one that's more than half. 70. So this one's got a couple. I was going to say it's just a basic two-step equation. It's got a few wrinkles to it. So the first thing, right, it says she used a 20% off coupon, and she paid $60. So we always want to think about not what we're saving or as much as what we're paying, right? So if you're saving 20%, then she paid, right, 80% of what she was supposed to pay. So the $60 represents 80% of what she was supposed to pay. Now, if you want to do that as a proportion, she paid 60 out of X, which represents 80 out of 100. Now, if you're going to use the proportion, I would think about 80% immediately as 4/5. And I would multiply my numerator and denominator by 15, right, and I'd get X is 75. Alternatively, if we want to go and solve this equation, which is not going to be maybe as friendly, right, we get 60 divided by 8, which is 7.5, times 10 is going to be 75. So one way or another, we've got to be able to figure out whether it's the proportion, whether it's the equation, whether it's, I don't know, you want to use a tape diagram, right? So once we know 60 is 80%, we can break that down and we can say, well, if I divide that by 4, then 20% would be 15. Multiply that by 5, we get 75. So now let's talk about this, right? So there's a fee of $40 plus $1 per mile. So we had to pay $40 for this fee. So we paid $35 at $1 per mile is 35 miles. All right, we got a pretty simple probability question. You just have to be really careful with the details. So the probability of red from 25 candies is 2/5. All right, that should be easy enough, right? I'm taking 1/5 of 25, which is 5, and I'm doubling it. So there's going to be 10 red. So now it says 10 red candies are removed, right? So now there's going to be 5 red. But the total number is obviously going to decrease by 5 as well. So there's not 25 candies anymore. There's 20 total candies. Meaning the probability is going to be 5/20, which is going to be 1/4. All right, 75. So it says each number is formed by doubling the previous number and then adding 1. So we have some work to do here, right? So if you've taken Algebra 1 and you've seen recursive sequences, that's what this is. If not, it's not a big deal. So it says the 9th number is 63. Okay, so if I want to find the next number, we multiply by 2 and add 1. So 63 times 2 is going to be 126, add 1 is 127. Now we need to work backwards, which shouldn't be too bad, right? So I had some number, the 8th number, I'll call it y. And when I double that number and add 1, I get 63. So if you're using a working backwards approach, you're basically just solving the two-step equation that I've got here, right? So now that we have this, we can just do what we just did, right? I don't need to set up another equation. I know the opposite of doubling and adding 1 is subtracting 1 and dividing by 2. So if I take 31 and subtract 1 to get 30 and divide by 2, I get 15. Right? And then the question is asking us, what's the 10th number minus the 7th number? So that we should be able to do without a problem. 127 minus 15 should get us 112. 76. So we have these scores. It says the highest and lowest are discarded. So I realize right away my highest is 9, my lowest is 8 2/10. So when I add these scores, right, I don't really want to add the whole number pieces because I know my answer is going to be 8 and something, 8 and a fraction, right? I don't know, tenths, hundredths, thousandths. My choices all have that. Well, 2 of them have tenths, 2 of them have thousands. So I'm just going to take the other pieces, right? These are my tenths. So if I add 4 and 6, I get 10, 18, 23, 32, right? So that's 32 hundredths. There's 5 numbers I divide by 5. 32 divided by 5 is 6 2/5, which is 6.4. Obviously, this is in the tenths place, so I need to move my decimal over since this was really 3 2/10. So we're going to add the 8, which we already had, with our 64 hundredths, and we get choice G. All right, so that's the kind of stuff that I said before, right? Normally, we may lean on our calculators for this, so we do need to be fluent with certain decimal operations, right? I'm not talking about, like I said, 3 by 3 multiplication or division, but basic operations with fractions, decimals, integers, we need to be pretty fluent with. All right, 77. This is an interesting one, right? Because the choices aren't that different, but the symbols are different. So a piece of wood is 4.5 feet long, right? It's cut into 2 pieces of different lengths, all right? So there's a lot of subtle details here. So if I cut this, right, it could look, right, there could be a really big piece and a really small piece. There could be 2 pieces that are almost the same, but one's a little bit bigger, but they're different. Okay, the shorter piece is X. Okay, so that's X. So I know if they were equal, right? Half of 4.5 is half of 2 and half of 4 and half of half, which is 2 1/4. So that would be my midpoint. So x is going to be less than 2.5, 2.25. Otherwise, they'd be equal. And it can't be 0, because 0 wouldn't actually be a piece. So we look at A and B, and we see that A and B are pretty similar. But B is ridiculous, because B says x could be 0, and it also says it could be 2.25. If it was 2.25, they would not be different lengths. They would be equal. If it was 0, it would not exist. So that makes no sense. So it's got to be choice A. 78, we've got a shaded region, right? That is not a shape you're going to easily be able to find the area of on its own. The strategy should be area of the big triangle minus the area of the unshaded, right? Just like that question we saw with the circle, the quarter circle and the square, we're going to take the area of the whole thing, subtract the stuff we don't want, and that will leave us with what we do want. So I've got half times my base times my height is going to be 200. That's going to be the area of the large one. I've got here, this little triangle here, that's half times my base of 10 times my height of 15. That's going to be my small one. Subtracting them is going to give me the difference, which is going to be 125, right? That one was pretty straightforward. 79, this one a lot of kids had some problems with, right? So we want the temperature, if they're giving us the temperatures in Fahrenheit, we want the difference in temperature Celsius. All right, so I'm going to go through what we probably should not do, right? Which is straight substitute, right? Not that it won't work, but it's going to be time consuming. So I'm going to say if Fahrenheit is 86, right, I need to find Celsius. Right? There's a lot I need to do here, right? I need to add negative 32, right? And then I need to multiply by the reciprocal of 9/5 C, which is 5/9. And let me make sure I do my subtraction, right? This is 54. I don't know what I was thinking was 62. So now we're going to get 54 divide 9, which is 6 times 5 is 30. All right. So that was a lot, right? I even made a subtraction mistake because I was not paying attention, not on my A game. Now I got to do the same thing with 68. Maybe I won't make a subtraction mistake this time, right? So we're going to do the same thing, right? We're going to add negative 32. I promise I will subtract right this time. We end up with 36. I'm front running here, right? So that's 9/5. I'm going to multiply by the reciprocal, which is 5/9. And 1/9 of 36 is 4 times 5 is 20. And the difference of 30 and 20 is 10. All right, so that's a good illustration of probably what not to do, right? I'm a math teacher, and I've done this problem before, and that took me a lot of space. It took me a lot of time. What we do want to think about is we want to think about the ratio of Fahrenheit to Celsius being 5:9. All right. So if the ratio of Fahrenheit to Celsius is 5:9, for every 5 digits Celsius, the temperature changes 9 degrees Fahrenheit. So what I'm going to do is I'm just going to subtract 86 and 68. And I'm going to say, what would an 18-degree difference be? Well, that should be pretty obvious. I'm just going to multiply by 2 and get 10. Right? That's the strategy. Right? We want to think about the ratio, right? The 9:5 ratio is really important, right? That specifically tells us the ratio from Fahrenheit to Celsius is 9:5. The other way around, it's going to be 5:9. That's why they gave you numbers that obviously had a difference that was a multiple of 9, okay? Doing it the way I did it in green and orange, it worked, but it took me, it was a lot of wasted time. Okay, so really we just want to take the difference in the temperatures. You could plug that in for Fahrenheit and then solve it that way. It's still not going to be great, but it's going to be easier to just use the ratio as 5:9. All right, 80. This should be an easy one, right? So x is an odd number. It says, what's the sum of the two even numbers closest to x? Well, if x is odd, then the next number, x plus 1, will be even. The next smallest number, x minus 1, will be even. Adding these together is going to be 2x plus 1 minus 1, which is just going to be 2x. You want to pick a number? Sure, you can pick 5. Right? What's going to be the sum of these two numbers? So if 5 is x, if I add 4 and 6, I get 10. That's going to be equal to 2 times 5, so 2x. Right? So that's a picking numbers approach. We shouldn't need it, but it works. 81, right? So this is one of these questions, right? What's our strategy going to be, right? Clearly we got a lot of numbers here, a lot of digits. So we need to do, it says, what's the amount of public debt per person, right? So we said before, debt per person means we're going to be doing some division here, right? The debt, which is the big number, divided by, right, per, boom, I put my slash, my division sign, the number of people. That's my smaller number, but still very big. All right, so first thing I'm going to do is I'm going to clear out 7 zeros, right? So we're dividing by 10 million. So my numerator is going to be 360000. My denominator, I killed off all those zeros, so I get 25. So I'm going to do something a little bit different here, right? I don't really want to do this division. I'm going to make my denominator bigger, right? Because if we have a denominator that's a power of 10, even if the numerator doesn't have tons of zeros, we can do the division a lot easier. Right, so I'm going to multiply the numerator and denominator by 4. So what's going to happen is this is just going to be 36 times 4, which is going to be 144. This is going to be 25 times 4, which is 100. And what that's going to allow us to do is it's going to allow us to knock off 2 more zeros. So now I have 14400, which is going to be choice B. All right, that's I would think what we want to do. We don't want to be doing the long division with the 25. We want to try to make it 100 or 1,000 or some other multiple. You could divide it by 5, I guess, but that's going to make the numerator really messy. So I think that's definitely going to be the easiest way to go about it. For the next one, this one should be quick, right? N is the midpoint, right? So this is where we need to make sure we're reading directions. So if n is the midpoint and there's x units to the left, then there's going to be x units to the right. Which segment is 2x minus y? Well, 2x is the whole thing, and if y is this piece, then 2x minus y is this piece, which is just going to be from P to Q. All right, area of a parallelogram is the base times the height. Is this a crucial formula to memorize? Well, it's an easy one, right? I don't know if it's one that I would say is absolutely necessary, right? In the sense that you can say, hey, let me take this piece and put it over here and make a rectangle. Now, of course, the issue is we don't know what that piece is. Could we make up anything? I guess we could, right? It doesn't really matter because now this is the 30 and this 20 just kind of gets shifted over here. And that's basically our kind of an informal proof for the area of a parallelogram. So it is good to know that it's going to be base times height, right? With the trapezoid, if you don't know the formula, that's when we start kind of cutting it up into pieces. But for a parallelogram, we should know base times height. All right, 84, we're going to use a little algebra, right? So we've got Tuesday, we've got Wednesday, we've got Thursday. So on Wednesday, we did 100 more than Tuesday. So if Tuesday is going to be x, Wednesday is going to be 100 more than x. And it says on Thursday there were 50 fewer than Tuesday, right? So we're looking x minus 50. Altogether now I've got 3x plus 50 loaves, and it says that that's equal to 230, right? So we should be able to add negative 50 on both sides, divide by 3, right? We get x is 60. I'm going to go back and substitute because I like to be sure that everything actually reconciles here. So if this is 60, 60 plus 100 is 160, which leaves us on Thursday with only 10. The question is asking us how many were produced on Wednesday. So sometimes we get excited. We're like, oh man, x is 60, great. Well, yeah, x is 60, but that's not the answer, right? The answer is what we have on Wednesday, and that's going to be our 160. All right, 85. I wish I had a better strategy for this one, right? So sometimes, right, so if the number of students, if all of them are multiples of the same number, we can use what's called a weighted average, which I won't get into now, but when we see it at some point, I will. So the point here is we're not just taking the average of the numbers, we need to multiply. So if 9 students got 60, that's going to be 540. If 7 students got 70, that's going to be 490. I don't need the zeros at the end, but it's really not going to change my computations, to be honest, whether they're there or not. If you want to get rid of them and bring them back at the end, you can go for it, but it really isn't going to change anything. Right, so when we add these up, we've got a 0 here. We've got our 20 here. Right, so we got 7, 10, 19, 2100, right? I've got 2100 scores, and when I add up the number of students, I'm going to have 17, 24, 28. So now we're going to think about how we do this computation. So what I'm going to think about is common factors. So 21 and 28 are multiples of 7. So if I divide by 7, this is going to give me a 4. 21 divided by a 7 is 3, meaning this is going to be 300. Now 300 divided by 4 is the same as 150 divided by 2, which is going to give 75, right? So we just want to find a way, ideally, that avoids using standard algorithm multiplication or division. 86, we add negative 4 on both sides, right? So we get x is greater than or equal to negative 1. Now just remember that if we multiply or divide by a negative, we change the direction of the symbol. We did not multiply or divide, we added a negative on both sides. So clearly it's going to be choice E, right? That one should have been pretty straightforward. The other choices didn't make a whole lot of sense. 87 is just following directions. We got three reciprocals. The reciprocal of 1/4 is 4. The reciprocal of 3 is a third. So it says when they're added together. Okay, well that's going to be 4 and 1/3, which is 13 thirds. What's the reciprocal of that sum? We take the reciprocal, which is 3/13, right? Pretty straightforward. All right, 88. So this one we can kind of do some cool stuff if you've done some algebra, and if not, this would be a good place to pick it up. It says, what's the difference between the areas? So we have a square that's 15 on a side, 15 squared minus 13 squared. So we could do 15 squared is 225 and 13 squared is 169 and subtract them and waste some time. This is an important algebraic property called the difference of two squares. So if you happen to have done a little bit of algebra and a little bit of factoring, you will know that when we have a difference of squares, it looks like this. Right? A squared minus b squared will always be equal to a plus ba minus b, right? So when we do this in algebra, usually we try to make a numerical connection too, because for something like this, that's going to allow me to do this, right? And I would much rather do 28 times 2 than 225 minus 169, right? It's going to work out the same way, but the difference of squares is going to make the computation a lot simpler. All right, another unit rate question. So same thing we said before, right? Oats per water. So I'm going to put oats per, draw my fraction, water. So my oats is 2/3, my water is 3 1/4, which if I make that an improper fraction should be 13 quarters. And again, you want to make the denominator 1 by multiplying numerator and denominator by 4/13. Go for it. I'm just going to do some straight division here. So I'm just going to do 2/3 times the reciprocal, and I get 8/39. All right. Could we test for reasonableness-ish, right? So in other words, I know that if we think about the amount of water, if I need to cut this down to 1, I'm dividing by about 3. I'm dividing by a little more than 3, but about 3. Right, so my oats is going to be something like 2/9-ish. So these are going to be out, but A and B are very close together. So we're not really going to just be able to use the choices. We would have to do the computations to check. All right, this is another one, kind of just a computation. 3/5 minus 1/2, right? 6/10 minus 5/10 is 1/10 x, right, is equal to 1/4 plus 2/3. So good way that we can add fractions like this. If we know my denominator is going to be 12, we can say I'm going to have 1 times 3 groups of 12. I'm going to have 4 times 2 groups of 12, or 12ths. Right? Now, obviously, we could just rewrite it with the common denominator, but I like this strategy as a little shortcut. Right? It's not a trick. I'm just saving myself a little bit of time and space there. So I'm going to multiply both sides by the reciprocal, which is 10. I'm going to get 110/12, which I should be able to simplify as 55/6, which is going to give me, 55/6. Look at that. I don't even need the mixed number. An improper fraction is always going to be better anyway. All right, percent of change, right? So this is not an explicitly percent of change question, but we will see some of those. It says, what was the increase in the sales tax? So we don't really need to calculate 7% and 7.5% of 200 and subtract. We can take the difference in the percents in this specific problem, right? So sometimes we'll see like, oh, well, if there's, 5% tax and you leave a 20% tip, can I just add these two together and take 25%? Well, it depends on the order, but generally we would say no. But for something like this, if I want the difference in percents, mathematically we can use the distributive property and prove that it is going to be 0.5%. So I want 0.5% of 200. Well, that should be easy, right? I should know 1% of 200 is 2. So 0.5% is going to be half of that, which is going to be 1. So that's going to be the difference. Now, if you found it, it would be the difference in 7% of 200, which is $14, and 7.5%, which is $15. But now we're just kind of wasting our own time there. So we just want to take the difference in the percents and take that percent of 200. 92, we just want to make sure we identify those absolute value symbols as what they are. So I'm going to do everything that's in my parentheses, right? -8 minus 12 is -20, plus -17 is -37. I add the opposite, that gives me -7. And the absolute value of -7 is 7. The absolute value of 24 is 24. So let's see what mistake I made here. Oh, sorry about that, -6, right? So -8 minus 12 is -20, plus -17 is -37, plus -30 plus +31 is -6, the absolute value of which is +6. Minus 24 is going to give us -18. So it's not +18 because the whole thing is not in an absolute value, right? If I had an absolute value around the whole thing, then I'm going to end up with +18. But I'm going to do the absolute value part on the left. That gives me 6 and not 7, as I made a little mistake there. And we got the absolute value of 24, and we subtract, we get -18. All right, 93. This is a good one. I thought this was a really creative question. A lot of students had trouble with this one, though, because there's a lot to do. Right, so it says the total is 100. So altogether, all of these expressions have to add to 100, right? So I'm just going to combine the like terms. 8k, 1k, -2k is going to be 7k, plus 30 plus 5 is plus 35. Nice, easy two-step equation. So 7k is going to be equal to, I'm sorry, that's going to be 65. I'm front running again, 35, and we get k is 5. So still a bunch that we have to do. So if k is 5, I'm going to substitute because I like to check. So I get 40. There's already 30 here. 30 minus 2k is 30 minus 10, which is 20. And k plus 5 is 5 plus 5, which is 10. Altogether, that adds up to 100. Great. So the amount of blue, it says what percentage? Now, they did that, but then they made it easy. So if you took the amount of blue and you just put that as your answer without rereading, you got it right, but not really for the right reason. Like if the total was 200, you would have got it wrong, right? So the amount of blue is only going to represent the percent if the total is 100, which they did here, right? They made that part kind of easy, so it's going to be 20%. All right, so we do see a lot of these number line questions. Sometimes they're pretty tough. They have fractions, they have decimals, they have negatives. This one should be pretty easy. So they give you the information in the text, which they don't have to give you the picture, but they give you the picture. So it says y in the midpoint of x and z. All right, so if we think about this like a number line, this would be 0, this would be 1, this would be 3, right? Because we're going from x, which is 0, over 1 to y, and then over 2 to z. So the midpoint of x and z is the midpoint of 0 and 3, which is going to be 1.5. So the difference between y, which is 1, and 1.5 is obviously going to be half. All right, percent of change, right? We should know percent of change is amount of change divided by original amount, right? Some teachers will say, well, it's the absolute value of the new, okay, new minus old, whatever. Let's streamline this. Let's make this as easy as possible. Change divided by the original, we want to make sure that it's always going to be, if it's increase, it's going to be a positive. If it's a decrease, we say that it's a 10% decrease, so like negative. So amount of change. So if the coffee went from 125 to 135. So, and guys, make sure we know this formula because this has been there sometimes 2 times, sometimes 3 times. I mean, you could see it literally right here on the same page. So the amount of change is 10 cents out of 125 cents. So I would say the key here is eliminate the decimal and simplify the fraction. So if I divide numerator and denominator by 5, I get 2 out of 25. Multiply by 4, I get 8 out of 100. That's 8%. Nice and easy. All right, 96. A lot of reading here. Right? So it turns out that it says she has a pyramid. Now, a pyramid could have different types of bases, and it says that there's going to be a square piece for the base and identical triangular pieces. And we want the whole surface area, including the base. Sometimes they don't include the base. All right, so if I'm going to try to draw this, and I don't need to, especially since my drawings are usually fairly terrible, it's going to look something like that. So the base is going to be 10 by 10, so the surface area of the square base is going to be 100. And each of the triangles is going to look like this. So I'm not going to use my crummy picture there. I'm going to use this one. So the height is going to be 12, and the base is going to be 10. So when I do 1/2 times my base times my height, I'm going to get 60. Now, obviously, there's going to be 4 of these triangles. So the sum of the 4 triangles, right, all you need to do is take the triangle that's there that I circled in red and find the area of it, right? So little extraneous information here. Right, it does turn out, if you draw the altitude, to be 5, 12, 13 triangles on both sides, just as kind of a cool aside, just not something we really need here. But they do get, usually if they give you a slant and a problem on the SHSAT, you don't need it, right? So I didn't bring it up, but the question before with the parallelogram, they gave us the slant. We didn't need it, right? We don't see Pythagorean theorem on the test anymore, unfortunately. So if they give you a slant, chances are you don't need it. Now, that's not an absolute, but more often than not, that's the case. So I've got my 240, which is my triangles. I've got my 100, which is my square base. I add them up, and I get 340. 97, we're back to percent of change, so the price increased from 625 to 675, so it was a 50-cent increase out of 625. We should know that all numbers that end in 00, 25, 50, or 75 are divisible by 25. So dividing by 25 will give me 2 out of 25, and look at that. They gave us the same sort of proportion here. We end up with 8% yet again. All right, 98, very, very common type of question involving averages, right? We have 5 games, averaged 8. So we always take the number of values times the average will always give us the sum. Now, in the first 4, we had 7 per game. What was the other score? Well, the other score is just going to be the difference, okay? So you can probably bank on maybe 1, possibly 2 of these questions per test, and they generally are pretty straightforward. All right, 99. So this is one, right? Sometimes on these practice tests, they give you computations that, don't follow my rule of this is not a computation test. Now, we're going to come up with some ways that we can deal with this, but this is not maybe the most straightforward one here. So let's take a look at what we can do. So we have 4 bags of oranges, and each bag has 8 oranges. So we've got 32 oranges that cost us $11.52, right? We're doing this in cents, no decimals. We want to know what 42 oranges is going to be. I'm going to simplify this thing as much as possible, right? I do not want to do any computations. So I'm going to do the easy part first. I'm going to divide, let's say, by 2 here. So I get 16 out of 21. All right, I got nothing else I can do horizontally. 16 and 21 have no common factors. So I can divide 1152 by 8, right, which will give me 144. And I can do that further. So if I divide by 2 again, I get 72. All right, so I'm done, but I still have to do this, which I don't want to do. So x is equal to 72 times 21. So the first thing I'm going to do is I'm going to multiply the ones digits. I'm going to say 2 times 1 is 2. So my answer is going to end in 2. And I look at my choices, and I'm going to say that's kind of dastardly, right? They gave me a whole bunch of numbers, so that's usually a good strategy for questions like this, and they all end in 2, except the first one. And from a reasonableness perspective, right, B and C are reasonable because 20 times 70 is 1,400, so D is out. And they gave us B and C within 10 cents. I don't really see the purpose of that. I don't know what whoever made this, I don't know what they were really thinking about. I'm going to be very honest. So if I want to do this in a sort of mental sort of way, I'm going to do 2 times 72 is 144, right? Times 10 is going to be 1440. I need to add another 72 to 1440. That's going to give me 1512. So I didn't have to do any standard algorithm stuff here. I could have. I mean, listen, obviously, if you do the cross multiplication from the beginning, you're going to have monstrous numbers. So that's going against my sort of my strategy of simplifying. So you're going to simplify it as much as you can, which is what I did. Eventually, we had to do the multiplication. All right, for 100. This one should be a nice, easy one when we think about the scale. So what I'm going to do is I'm going to make the denominator an integer by multiplying the numerator and denominator by 1,000. So my numerator, the decimal moves 3 places. My denominator, it moves 3 places as well. So 1, 2, 3, 1, 2, 3. So we got 3,600 divide 18. Well, that should be easy because 36 divide 18 is 2. So I get 200. Okay. 101. So this one's pretty easy. There's a few steps here, but I think overall it's pretty easy. So there's the 500-gallon capacity that we're going to use at the end for the percentage. So it's got 75 gallons plus 5 gallons per minute for 45 minutes. Well, that should be pretty easy, right? That should be 225. So I end up with 300 gallons out of my total capacity. Well, that should be nice and easy, right? That's 3/5. We should know 3/5 is 60%. All right, 102, she needs 2 straps, and each strap requires 1 1/4, so 2 times 1 1/4 is 2.5. $5 times 2.5. 2 groups of 5 is 10. Half of 5 is 250. Add them together, we get $12.50, right? Nice and easy. All right, so as promised, we do see sometimes, like we see 103, 105, these proportional relationship type questions, right? So this says that the number of test questions correct is X. So one correct question will be the score, which is 5/4. So one question gets you 5/4 of a point. Each question is worth 5/4 or 1 1/4 points. All right, the next one we can do just using scale. So this is a proportion, right? They surveyed 200 people. So 45 out of 200 people did something, right? We don't care really what it is. We want to know what that would be out of 25,000. Right? So I'll do the computation eventually, but really what I realize is this number here is going to be less than a quarter. Right? So a quarter of 25,000 is going to be 6,250. So it's got to be less than that. So only E works. That's what they want you to do. Right? Because look at what, yeah, I can divide out 100 here. I can divide out 100 here. I can't really do too much more than that, right? I can get 2x equals and I can multiply those monstrous numbers. It's also going to be an estimate, right? So the thing is that you're going to realize that, well, I could divide out 2 here, sorry. And I can multiply 45 and 125, which I will not do because we don't have to, right? Again, we know it's got to be less than a quarter, so that should have been an easy one. All right, the next one, you can make a table, right? X and Y, right? And you could say that if the number of days is X and the number of, right? So, I mean, listen, we can go back to Y equals KX, right? So if you were in 7th grade at all, ever, you probably spent a week on proportional relationships until your brain was numb on it. So we know that K, the constant of proportionality, if we solve this for K, is equal to Y divide X. So literally, if Y is 17 and X is 3, this would be 17/3. We can also take what's here and substitute it into the equations and say, which of these is going to be true? Well, if I replace X with 3 and replace X with 17, 3/17 of 3 is certainly not 17. So the only one that makes sense from that perspective is C, but just use K is equal to Y divided by X, like I'm sure you heard way too much in 7th grade. 106, so it says she walks 3 miles and then another 2.5, so she walked 5.5 miles, and then she came home, 1 2/3, how much is left? So we can convert this into sixths if we want, right? So this is not really one we need a specific strategy. So if I take away 1 3/6, it gets me to 4. Taking away another sixth gets me to 3 5/6. So you want to make them both into improper. I mean, it's just a matter of preference how you need to do the computation. That's not something I think we need a specific strategy for. All right, back here, inches per year. I'm going to go back to my inches per divided by years. So 1 1/4 inches in 1/3 of a year. Now, really, we should just be multiplying by 3 from the beginning, right? If I want to find out 1 year, 1 1/4 times 3 is 3 groups of 1 and 3 groups of 1/4, which is 3 3/4. Number 108, we have 3/100 minus 3/10. Could you factor out the 3? Yeah, if you know how to factor, right? I mean, that's really the best way to do this, right? So we get 3 times negative 9/10 if you're going to factor. Most of us probably won't, which is okay. So we're doing really, if you annex the decimal, 3 minus 30, which is negative 27. And we're going to put our decimal here, right? So either way, that's just a computational question. 109 is not a computational question. So 109, I'm going to say, oh man, I don't want to do this. And I'm going to look at the choices and I'm going to say, great. Unlike that ridiculous orange question where the choices were close together, my choices are way far apart. So all I need to do is do 10 plus negative 5 is 5, plus 2 3/4. I'll move that up to 3, I mean. All right, so that's the only one that's close. You don't have to do anything, right? You just need to approximate the values because the whole numbers and the mixed numbers are so far apart. They're all apart by 5 or 6. You don't have to do very much there. All right, simple interest. Now the question, the issue here is how much will he have in the account, right? So we need to take 350, we need to take 5%, right? So what am I going to do here? I'm going to take 10%, right? So 10% is 1/10, which is 35. So 5% is going to be half of 35, which is going to be 17.5. That's his interest. So choice E is, we think maybe that's right, but that's his interest. So we need to take his 350. That's his money that's sitting in his account. He's getting paid $17.50 in interest. We need to add that together, which is going to be G. The rest of the choices are all kind of ridiculous. 111. So the probability of something occurring is either 1/20th or let's call it 5%, right? So 50% would be equally likely. That would be maybe D, I guess. Impossible would be 0. Unlikely would be something that's below, let's say, I don't know, 25. There's no real strict rules. We'll say close to 0. So certainly 5%, right? If they say 5% chance of rain, you're probably not going to bring your umbrella. I would say that's going to be unlikely. We got another proportional relationship here. So we realize that all we're doing here is multiplying by 1.5. So 11 times 1.5 is one group of 11 plus half of 11. So we got 16.5. Nice and easy. All right, another midpoint question. So the midpoint of PQ. So P to Q. So one way we can find the midpoint, right, and I don't generally do this, is just to take the average. Now, I like to think about it as from -3 to 1, there's 4 units. Half of 4 units is 2, so it's going to be 2 units from each of them. So -1 is 2 units from P and 2 units from Q. From an algorithm perspective, you just take the average. Now, what about from Q to R? Well, that would be the same thing, right? So if we want to do it this way, it's going to be 8 halves. I just think about it as, there's 6 units here. So half of 6 is 3. I can add, it's going to be 3 units from 1 and 3 units from 7. That's going to be 4. So the difference between 4 and -1 obviously should be 5. All right, and finally, right, so we have another pretty simple proportional relationship. They don't even really need to give us both of them, right? So 4 cups are $12. Like, really? All right, this is the way, I guess they want us to finish strong, so it's going to be $3 per cup. Cups per dollar is a really strange, it's not something that would be impossible, but a little strange. All right, so I hope you guys enjoyed the video. I started going a little bit faster at the end because they do start to get a little bit long, so obviously we can pause, we can go back to things we need. Questions, comments, concerns, you can leave a comment below, and I hope you guys learned something, and I hope you guys come back and check out some of my other videos.